Did you know that spiders are our personal tiny bouncers? Well, they are. Species diversity of spiders keep other insects in check, reducing the risks not only of diseases, but of pesky animals too. In our games, protecting predators isn't just nice, it's crucial for balance. Hi, I am Sergio Jacinto. Thank you for joining us today. I will be walking you through one of our science-based simulation games that we use to map our dependencies on nature and mitigate our financial and operation risks while creating value. The nature game, the Biodiversity Collage, that you see here in the screen, is a collaborative and playful science-based game simulation to understand and map our dependency of biodiversity. First, some general information on the game and the credibility of the data. The game is based on science, specifically on the IPBES reports. This stands for Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. This is an independent organization with 147 countries as members. It was established to improve communication between science, policy, and biodiversity. Its reports are made by scientists from all over the world, from different cultures, different political systems, and different geographies. They publish their findings in the IPBES reports that inform this game. This fun collaborative simulation is played with cards that participants organize together. At the end, it will look something like the diagram that you see here on the screen. It can be delivered in presence or online in groups of multiple of 8 participants. It's easy scalable through facilitator training programs, and it has a time investment of only 3.5 hours. It's played in 4 main stages. Understanding the logic of the simulation, running the simulation, the game itself, the bulk of the workshop of the science-based game, then developing foresight, the more fun part, where we explore and anticipate possible futures, and where we strategize. First, let me show you how we start the game to understand the logic of the simulation. We start by showing participants a system that's in balance, or better said, ask them to recreate a balanced ecosystem. In this case, the North Carolina. We ask them 2 questions. Where do they live, regarding the animals here, and what do they eat? Here we can see sharks, cow nose rays, bay scallops, and plankton. They all live in the North Carolina under the ocean climate. The scallops live in the seagrass bed and they eat the plankton. The cow nose rays eat the scallops and the sharks eat the cow nose rays. Then we tell people a story. We introduce a disruption. And the story is that in North Carolina has long been a major scallop fishing center. In the 1930s, over 600,000 kilos, 600 tons of scallops were harvested annually. In the 1990s, North Carolina scallop fishermen observed the collapse in the scallop population. In 2007, 30 years ago, the last fishery in the state closed. What do you think happened? I'm going to invite you to pause the video for a minute and write down a couple of ideas of what you think might have happened. I promise it's not what you expected. Were you able to guess? Well, the answer is overfishing of the sharks, 95% less sharks, which resulted in an increase of cow nose rays, no predator, which in turn eat the scallops. And while the cow nose rays eat the scallops, they cause the tearing of seagrass bed and disrupt the environment where other animals live. So what are the consequences of this for business? Well, fishing companies of sharks, scallop bays, are out of business. Fishermen are out of their jobs. Scallop transformation industry ceases to exist. No more exporting products. No more building ships for this purpose. No more fuel sold to these boats. And no more fishing. By the way, this is a true story. So where do you go from here? After this, we play the game, where we run people for the bulk of the workshop. Here, we learn concepts like ecosystem services, human activities, the drivers of biodiversity erosion, and the consequence of erosion of biodiversity. We learn about ecosystem services like pollination, like soil formation or water. We learn about very important concepts like inadaptation of species, degradation of ecosystem services that are essential for business, and erosion of biodiversity. With this information, we are able to go into a more fun part, more interesting part for us as managers. We go into foresight, where we can explore, anticipate, and prepare for multiple potential futures that inform our present day decision making and secure our business continuity. So, what might this look like? So, the IPCC, Intergovernmental Panel of Climate Change, another very important international organization, tells us that by 2030, 2040, we might have from 2 to 3 degrees of global warming. And that might mean that we have between 10 to 20% of biodiversity loss. So what might that mean for us, for business? Well, let's take an example of a bottle company. I thought this example was nice. So we depend on aquifer recharge for raw materials. We need the forest and inlet lands that capture rain. We might have in the future stranded assets because the wells run dry, and our right to operate from society is revoked because of competing uses. We depend on natural filtration from the soil and the root systems to remove the toxins. And that means that we need a product purity that comes from nature. It means that we might have an operating expenditure spike due to heavy investment needed in chemical and mechanical treatments. We might have a flooding near our plants because the vegetation, the riparian buffers of the vegetation might not be there. We might have an increase in insurance and extreme capital expenditure due to flash flooding, for example. We might have a loss of the microclimate that we use for regulation for our well-being. That might mean that we have higher costs for refrigeration and extreme heat, or cooling for energy. We might lose pollination and soil health. It might mean that our crop yields go down, and if we depend on them for bioplastic, for example, it might mean that the feedstock of our products skyrockets due to crop failure. So how does this look visually? Well, we depend on natural capital for watersheds, for water forests, for soil health. What are the implications in these scenarios? We might lose a recharge rate of our primary assets. The pumping costs might go down, the cooling costs might go up. The social license to operate goes down as the community competes for shrinking pool of the same resources. Then we go into debate. Then we think about ideas for these problems, how we can solve, how we can anticipate, how we can mitigate the impacts and capitalize from that. So we might create infiltration lagoons or dry wells to capture surface runoff directly into the ground. We might consciously, strategically manage the aquifer recharge into infiltration bases. We might partner with local landowners and restore native forests and wetlands in the recharge zone. It might not capitalize in this from marketing, for example, in our communication. We might restore the vegetation along the banks to prevent flooding. In short, what is the business advantage of science-based simulation and of using this for foresight or foreseeing the future? Well, we instill resilience by guaranteeing a business continuity, by guaranteeing the asset valuation in the future. By aligning ourselves with science, we guarantee stakeholder and regulatory trust, and we lower our risk from legislation or insurance, for example. By scenario planning, we proactively plan versus reactively reacting, which might mean extreme capital expenditure in the future. And finally, we guarantee long-term operation stability, which is what we really want. I hope you enjoyed, and I hope we can have a conversation soon. Thank you.